Are computers not very, very different from brains? Well, yes, they are, right? How many computers would it take to emulate a brain? A lot. Right? Individual neurons are extremely complicated. Cells are very complicated. But how many brains would it take to emulate a computer? Right, this question is the one that actually matters. And you would need a lot of human brains to run macOS, because human brains are very indeterministic and unreliable and slow. Right, so we are very good at what we do, and the software that runs on us is optimized for the elements that runs the software, but it's not directly comparable in this sense. If we, for instance, look at the weights of Stable Diffusion, they're just 2 gigabytes. And in these 2 gigabytes, you have all the celebrities, all the dinosaurs, all the plants, all the artistic styles, everything, the whole visual universe. There's much, much more fidelity than any single human alive. Right, it's just 2 gigabytes, and it's like 80% of what your brain is doing. So I think this estimate that Matthias gave us today, in conjunction with the Turing paper, that it's something between 10 billion bits or petabyte, right, is still quite conservative. It's quite pessimistic compared to what you can do with just 2 gigabytes. Right? I think these 2 gigabytes is more than what my brain can do. And if you think about it, I'm not getting that old. I'm not able to form more than 1 million concepts, just because of time and the number of events that my brain can process. So in some sense, we have to realize that even though these models can do relatively little, they do this with vastly more power than we do. They brute force it still. And so if we compare digital computation and biological computation, we see they're very different, and there is a lot of treasure on the biological side that AI hasn't started to touch yet. Right, the digital computers are deterministic and they are linear. We go from state to state, where the biological system is branching and merging, and the state in the digital computer is always synchronous. In biology, it's asynchronous. There's no global clock between your neurons. They have to figure this out by themselves. Everything in our own brain is self-organized, which means it's locally controlled, bottom-up. All the centralized structure is the result of individual cells getting along and imposing structure on themselves. Similar to a corporation, right? All the structure in a corporation is people. And all the structure that evolves in there or in a society is people. And everything that we build is happening over generations, finding ways for the people to talk to each other in particular ways. So all the global structure emerges. And that's quite different from a machine learning algorithm, where you have one rule that you impose on the entire memory of the computer and many GPUs, and everything does the same thing in synchrony because it has no other choice. And we also see that the brain is very slow. Like the signal processing is so slow that it takes about 300 milliseconds for a signal to go through the entire neocortex. It's comparable to fetching data from the other side of the globe over the internet, right? Or birth. And so our thinking happens basically at the speed of sound, whereas our GPUs run at an appreciable fraction of the speed of light already. And if we were able to get digital hardware to run with similar principles as biological one, maybe we would be like trees to them, right? But the AI would look at us and realize, okay, there is some thinking going on and some environmental adaptation, but it's at glacially slow speed.